Welcome everyone to our Advanced OpenACC course. Thanks a lot for joining. My name is Julia Levitas. I'm a product manager at our Tesla group and will help with the class today. So let me first go quickly through the agenda. So today is our second session and we will be covering profiling, and this is an office hour. We have two instructors who can help you with the questions. And before we get started, let me cover some logistics. Every session of the course will be recorded and available for you to review on our OpenACC courses page. You can easily find this page by typing in Advanced OpenACC course in Google, and the first link will be course page with the recording. It takes some time to post the recording, so the recording will be available tomorrow, but I will try to do it as fast as possible. And if you have any questions, please email them to openacc@nvidia.com. All the lines are muted, so please submit your questions for a Q&A pod on your right side. We will do our best to answer as many questions as we can today. In case we won't get to every single answer, we also have a next lecture on June 2nd, so we can cover some of them there. And also after this session, we will be posting the transcribed Q&A, and we will be answering some questions there as well. So if you did not hear the answer today, please make sure that you check this Q&A document. I think we are done with their instructions, and then I would like to introduce you to our two instructors today. So Scott Bersdorf is a profile engineer in PGI and knows everything about the profiler and will be happy to answer your questions. He will go over some homework through the visual profiler as well today, so be ready to ask him questions. We also have Jeff Larkin. He's working at NVIDIA, and most probably you know him from our previous course last year. He is working on accelerating HPC applications and located in Oak Ridge National Lab. So both of them are happy to assist you today. So feel free to use the Q&A pod to ask questions. And with that said, we are ready to get going. Scott, you there?
Yes, thanks, Julia. All right, so before we get started on this Q&A, there's some questions from the last lecture that I go ahead and answer right now. The first is there a way to use OpenACC with Python? And the answer is no, there's no OpenACC API for Python that I'm aware of. And for question 2, OpenACC and CUDA libraries are definitely compatible. And there's lots of examples where you use both of those or all three together in the same application. For question 3, this is something to think about. So OpenACC is fundamentally designed to work off of the inherent parallelism in your application. So if you already have functions that are very dependent on the order of operations and couldn't be run in parallel, you're unlikely to get much benefit out of OpenACC. So that's something you want to look at in your application first before you start jumping into OpenACC. For question 4, so when you have nested calls that are all going to be accelerated on the GPU, you have to mark all of those as regions that need to be accelerated on the GPU. That's a little tedious, but that's the state of the situation right now. And then finally, for question 5, this is something that looks to be promising, but is not currently supported, at least with the PGI compilers. So you can target a GPU with your application, or you could target multi-core, but targeting both right now is not currently supported. All right. Well, please feel free to start asking questions in the Q&A pod. As those come in, we'll do our best to answer them. But first, I wanted to give you guys a little bit of a demo of the PGProf profiler. as it relates to the homework you assigned last week. So I have already profiled the stage 2 and 3, or to task 2 and 3 of the homework from last week, and I've opened those profiles in pgprof, and I wanted to give you guys a little bit of view of what that looks like. So right now we're looking at the stage 2 profiler, and on the top here we have our timeline. So you can see all the events that are happening in this program's execution along this timeline. Each row of this timeline is a different type of event shown. So for up here, we have OpenACC events. So for example, at this very beginning, you can look at the lower right hand of my screen to see what event I'm currently hovered over, and this is a compute construct. As shown here, it shows you not only what it is, but at what file and line number it's at. Next we have, so even though you're programming directly to OpenACC, the CUDA driver calls are being invoked by the compiler runtime. And so those events show up down here. So for example, here's a memory alloc. And then finally down here, you have under this, I ran on a Tesla K40C, so you see we have a context, a single context, and it has a series of memory copy events going on, as well as these 4 different compute kernels. So you get some more details about this first one here. You can get the start and end time, the duration. You can also get some information about occupancy, for example, and shared memory usage. There's a lot more you can see as well if you were to want to dive into the performance on the GPU. Another thing that I don't think Ty went over very much last week, but it's a feature of the profiler, is this CPU details view here. So in task 2, the second stage of the homework, this is before we've accelerated the sum routine on the GPU. So you can see it's taking a significant amount of time. You can double click on this here, and it will actually bring up the source code for that event. So you can see the sum2 function right here at the top. So also in the same file, we have the actual actual that were accelerated. So if we go to MIG2D here and scroll past these comments a little bit farther, here we go. So now we can see we have some OpenACC directives at this loop right here. We have one here at this loop, and then there's an inner loop below that also has OpenACC. So also, the compiler recognizes this information and will annotate the source code with information about what the compiler is doing at these line numbers. And those are in these little boxes here. So for example, this kernel was generated at this line number, and these operations were performed. So we've got some copy-ins going on. These are the same ones you'd see when you were compiling your code, but they're in the profiler here for your reference as well. All right, so we can also look at this stage 3 task, the application. So here we go. This opens a different session. So we're looking at now a different profile after we've already accelerated and optimized the code further. You can see there's no longer a sum routine showing up at the high level of our CPU details as it's now accelerated. You can also confirm that by looking at, and you can see there's now this sum2 GPU kernel being executed here on this line. Let's zoom in a little bit to this timeline. So I zoomed out here. I'll show you the whole thing. So we got 20 seconds of execution shown right now, but it's hard to see much detail. You have to need to get in really close. So using the, let's see. Experiencing a little bit of network lag right now. Let's see if we can zoom in here. There we go. So it'll be much easier to see how the different components interact together when you get into the fine detail of what's going on. So get down so we're just viewing a couple of kernels at once. So here's our MIG2D kernel, and you can see it's highlighted. When we select it, it also highlights up here in the top bars, these two events here. These are the launch events that are associated with this kernel execution. Altogether, this whole thing is enclosed in this one OpenACC compute construct. You can see on the top level of your OpenACC view. Inside that, you have the little bit of event that does a launch, in-queue launch, and the rest of the time spent waiting for that kernel to complete. And you can see that that's associated with, an actual driver call, this string synchronize. So you can see how the different components of your application work together to produce this profile. All right, we can also take a look at some of the memory copies going on here. There's a very small amount of memory traffic right here. Let's see if we can zoom in a little closer.
Scott, there are also a couple of questions came in. You
Okay.
should be able to see them, so whenever you have a chance, you can answer those. Thank you.
So for this memory copy here, we got a memory copy from the hosted device. You can see happening on the GPU, and that's a result of this in-queue upload event here, which is part of this inner data region, and with this file line number. So let me start looking at some of the questions here you have. Can you capture trace on one host from the command line via environment variables and analyze it with the GUI profiler on another? And you absolutely can. That's definitely something you want to look at if you're running on a remote system, but you want to visualize the trace data on your local system. What you'll need to do is you'll need to use the command line pgprof to profile the application. There's an option to output that profile as a file. And then you can just copy that file to your local system. And when you pull up in your visual profile, you want to go File, Import, select pgprof profile file, and select it from your file system on the next pane here. So single process, and you want to browse for it on your file system and select it here. That's exactly what I did for these profiles that I'm showing right now. I have another question about the OpenACC directives. So sometimes you will get information back from the profiler that a particular OpenACC definition that's generated by the compiler is not recognized by the profiler. And that's due to the profiler maybe lagging behind the compiler in a version. So if you're using a new version of the compiler, then the profiler is totally fine to do, but you may not be able to recognize some of the newly added CCFF information that the compiler is generating. But otherwise, your profile will be complete. All right. Any other questions? Here we go. Here's another question. So is there a simple way to focus on loop performance and limit the view to one loop, or perhaps averaging over different loops? So that is a good question, because when you're looking at this timeline view, you're actually seeing, many different possible loops, and you're seeing them all aggregated together in a single timeline. So you can look at if the loops are accelerated around the GPU. You can look specifically at the GPU kernel that's been generated by the compiler for that. So that by selecting, say, this one here, we can get, we'll just highlight those events. So this GPU details pane here. And if I can click summary view here, so you can see I've just highlighted just the MIG2D kernel, and I can get information just about it, the number of invocations, its average duration, its dynamic memory usage, if any. Yes, the help from the source code here, when you hover on these little notes, they're generated by the compiler with minfo equals CCFF. So they're called Common Compiler Feedback Format, so the CCFF there. And that's not on by default when you compile with BGI, so that's an additional option you need to add. So the option would be minfo equals CCFF. So in the case that you don't have a GPU at all, you can definitely continue to use the PGI profiler. You will just see information about what's happening on your CPU. So you'll be looking at primarily the CPU details pane here. We'll continue to have information about your program's execution, and you'll be able to look at your source code and see messages related to how the compiler is accelerating your code on your CPU via multi-core. All right, I'm going to switch back to the slides now. Now, how are we doing on questions, Julia? Yeah, so this is your opportunity to ask anything about the OpenACC, how to program it or how to profile it. You know, if you haven't started on homework yet, I would definitely recommend going through it. It walks you through a lot of the steps that you're likely to take on your own application if you're working on accelerating it with OpenACC.
Hi, Scott. While we're paused here, I thought I can go through a little more detail on two of these questions and see if that spurs some more questions here.
Yeah, go ahead.
So the first question about OpenACC in Python, and as Scott said, there is not a direct way to use OpenACC in Python. It's strictly C, C++, and Fortran. Of course, you could develop a library using OpenACC in one of those languages and bind that into Python, but you can't use it directly. But I do want to point people to Anaconda Accelerate, and let me see if I can share my screen here so people could see that.
You'll need to grab presenter.
Yep. So as soon as I have that, share. Okay, so this is the Continuum.io website, and they have a product called Anaconda Accelerate, which is a Python interpreter that does interface to CUDA. You can see down as I scroll down here, they have interfaces directly into cuBLAS and cuSparse and a lot of the CUDA libraries. In addition, I'll point out the Parallel for All blog, which is NVIDIA's developer blog, that we have some examples here. As you can see, you can actually do some very high-level programming like OpenACC using these directives that are inside of Python. So if you are a Python developer, there are options for you. You can't use OpenACC directly, but you can use the bindings, or you can also take a look at this Numba Pro, which is part of Anaconda Accelerate. So I would definitely encourage people to check that out. You can also find information here on developer.nvidia.com under the How to CUDA Python. So that was question one, and then I believe question two was about interoperability. And I do want to point people to there's some examples that I've put up in my personal GitHub that has lots and lots of every possible combination I've come up with for mixing OpenACC with other programming models. So, for example, if you have OpenACC and you want to call into CUDA and how to do that within here. So if you're interested in mixing and matching, then I encourage you to check out that this repository here, and I put a link in the chat for people.
Great, thanks a lot, Jeff. There is actually one more question. If you have more than one GPU, can you target a specific card?
Absolutely. So let me, while I'm in the GitHub here, see if I can find. So there was a lecture that we did in the original OpenACC course, or it's been updated more recently with GTC. So if you search for, if you go to the GPU Technology Conference website and search for Advanced OpenACC Programming, I actually have an example where we take a code here and I target it across multiple GPUs. So I actually use the ACC set device num as a function call where you can say set device 0 or set device 1, and it will direct all of your work to the particular devices. So there is an example here online, and search on GPU TechConf for the Advanced OpenACC Programming course, and you should be able to find the information on there about how to do that. Or, as I said, if you can't find that, also search for the OpenACC course we did last fall. Lecture number 4 had how to use multiple devices as well.
Thank you, Jeff. And one more question. Can we use OpenACC in R?
In R. Now, I have not heard anyone attempt to do that. The only languages that OpenACC supports in the specification are C, C++, and Fortran. Just like the answer with Python, if you want to write a library, particular function calls in C or Fortran or C++, whatever you're comfortable with, accelerate those with OpenACC, then you can use, I believe R also has language bindings where you can call into those functions, but you cannot actually annotate R with OpenACC.
Great, thanks a lot. And there was another question, can I increase the amount of stack heap in the NetBeans IDE 802 shell using OpenACC? So there was a confirmation about this question that just came in.
So that's the NetBeans IDE.
Yeah.
I'm not sure. So the NetBeans IDE, it's simply an editor. I really don't know much about how to adjust any of the stack sizes or anything like that in there. OpenACC does not directly have environment variables or anything like that for increasing stack sizes or anything like that.
Okay. Thanks a lot. And again, just a reminder, there's a great opportunity. We have 2 instructors today here. You can answer as many questions as you want. So please submit them through the Q&A pod. Okay. Scott, do you want to cover what the profiler, what kind of features it has? So we have, I think, one of the slides that can do that while we're waiting for the next questions.
Yes, I can. So PPProf is designed to be a unified profiler, and that's equally applicable to applications running on a CPU or GPU. It wasn't originally designed specifically for OpenACC, so but it has a lot of extra features that help you when you're programming OpenACC. So one of those is it will actually keep track of what's happening in the OpenACC runtime via a tools interface that's part of the OpenACC specification. So when you see events on that timeline, like those compute constructs, those come directly from the OpenACC runtime. So for the CPU side, we track all the threads running on your application, and we track the time spent in every level of your application by sampling it periodically. So at a given point in time, your application will be at some location in your application, and we will track where that is and what routines called it. So you'll be able to see, for example, if your application is spending a lot of time in some low-level function, you'll be able to track each of the functions that called it all the way back up to your main program.
Scott, do you mind opening up the profile and maybe showing it in there? People are asking where exactly you can use those features.
Come back to this. All right. So there we go. Let's bring it back up. So on the CPU side, I was saying we have the ability to track the call tree of your application. So right now we're not seeing that. It's all flat. But if you click here, you'll see it will organize the tree in a top-down view, so callers first. So you'll be able to see, let's go to thread 0. Thread 0 is actually just pulling the application. Thread 1 is, let's see, and maybe you want thread 0. go to this one because there's more stuff going on the CPU side. Yeah, here we go. So we've got Meg2D, for example. So you have this function call here, and we can see what functions are called inside of it. So these are all functions that are part of the PGI OpenACC runtime, for example. It will also track. It will also organize the, your profile by which libraries it was called. So we can see here that we have time spent in the pthreads library, and libc, and your actual application here. And you can get the percentages of time for each of those. So that's what you'll be able to see from the CPU side. From the GPU side, we've got this call tree. We have the GPU details pane, which gives you some details about your application. You can also start looking at more detailed analysis on the GPU. This is a guided analysis pane. So you can start, if you want to really dig down deep at the absolute best performance on the GPU for a given kernel, you can start with this analysis here. You can start by analyzing your GPU usage and individual kernels execution time. Let's see. We also have a dependency analysis feature. So if you want to know, you have a lot of things going on in your application, you'd like to know which events are on your critical path of the application, which ones are actually limiting you in your performance. You can run the dependency analysis from here and get information about that as well. So all this information is part of the, documented in our help feature. So you can go here and you can look at the help contents for all these different features. There's also a PF online, and let me bring the chat up here. This is the website for that. I will post on the chat momentarily once I grab that. Yeah, let's see. Is any more questions coming in? Does guided analysis work with remote applications? So, yes, or at least you can profile your application and gather all the metrics it needs to do the guided analysis on the command line. To actually step through the guided analysis, you'll need the GUI interface. And there's instructions on how to do that in the command line. You will need to add an option to collect all the metrics. And then once you've collected all those metrics and saved them to a profile file, you can open the profile file here in pgprof, and you can look through the guided analysis. Otherwise, if you were to launch your application in the GUI mode, you can actually perform the guided analysis on demand, in which case the profiler itself would launch the GPU application, collect the metrics, and then return back to you the information it collected.
Scott, there's also one question regarding if it's possible to use Fortran 90 with the profiler.
Yes, it's absolutely possible to use Fortran. you'll be able to open the Fortran code on the source viewer, and you'll be able to see annotations for Fortran as well as C.
Okay, great. Thank you. Okay, any other questions? I know, like, based on the poll, majority of you haven't started the hands-on labs. If you have any question regarding how to access those, it's also, you're welcome to ask the question, or maybe any other details. Okay, let's give it a couple more minutes if we have more questions. If not, we can wrap up a little bit early then. So let me go through some links and information additional information you can refer to. So we collected a few links for you. So there is a previous OpenACC course, kind of more introductory level we did last fall. Everything is recorded. There are Q&As. You're welcome to reach out to listen to those recordings and read the Q&As. There is also a PGI website that has a lot of resources on OpenACC. Stack Overflow is another place to go. All the OpenACC questions are tagged there, and you can search for the answers. OpenACC Toolkit, I see that a lot of you already downloaded. That's great. So let us know what's your experience. But this is the free version for academia, and we have a 90-day trial for the rest for industry. Perl4All blog has a few articles on OpenACC, which is also a great read. We recently had our GTC conference, and there were a lot of OpenACC talks in there as well. So it's a great library that you can use. And of course, the OpenACC organization, that website has a tremendous number of resources. That's just a great place to go. Okay, let me see if we have more questions.
So also, Julia, I just posted a link to the PDProf Users Guide. So in addition to being able to look at the help inside the application, you can also download this PDF from the PGI website that will show you all the details about how to do all the operations that I've shown today and much more.
Great, thanks. Okay, and I just wanted to remind you that we're going to have our next lecture that will be more focused on the multi-GPU programming. And it's going to happen exactly in a week, 9 o'clock Pacific time on June 2nd. And it will be also followed by the office hour. So please join, and we'll be covering a lot of interesting topics during that hour. So again, if you have any questions, please submit them from the Q&A pod. We are also taking questions online. There is email openacc@nvidia.com. So if you have any troubles with homework, accessing it, or any other questions, please feel free to ping us, and we will do our best to help. Okay, I don't see anything else coming in, so I believe we'll just close it up right now and see you all in a week during our next class. Thank you so much for attending. Really appreciate your questions today. Thank you.